Fine. Thank you very much all for joining us today. We have 40 people on the line today, so good show. Well done. You clearly are very interested in the topic, which is good, big data and using data effectively. Just before I hand off to Infinitive, who are going to be doing the session today, well done to anyone who got their first of a kind applications in this time last week. I'm sure it was very stressful leading up to it. If you still have excitement to do more applications, I've been asked to remind you that Transport for Wales Accelerator is open at the moment for another 2 weeks. I have more details if you want to know about that, or you can just go to the TFW Labs website and apply for that, because there's more exciting things to do. But without further ado, I shall hand over to Infinitive Group, and I am driving the slides, so you'll have to tell me when the next slide is, but I'll mute myself until then.
Hi everyone, I'm Ben Craze, Infinitive Group CEO. We're a founding member of the Rail Innovation Group, so I've attended many of these and I know quite a few. Looking forward to present with Porterbrook today on leveraging existing data.
Great.
I'll pass over to Chris.
Find the unmute button. Hi, I'm Chris. I'm the Chief Technology Officer of Infinitive Group. I was part of the team that implemented the algorithm that you're about to hear about. Next, pass on to Gav.
Good afternoon. My name's Gavin Beattie. I'm Head of Systems Engineering at Infinitive Group. And I'll pass on to Steph.
Hi, I'm Steph Klecker. I know a few of you on the call. So I'm Head of Digital Services at Porterbrook. And just for anyone who doesn't know, Porterbrook own nearly a third of all the passenger rolling stock in the UK. So the idea of this particular project was part of a big strategy, which is how can we use the data on trains to actually get some real value delivered to the industry. So hopefully this will be an interesting presentation to show you how we did that.
So as I mentioned in my introduction, we're here with Porterbrook to talk through how we used existing data to drive better, insightful decisions for one of Porterbrook's clients. We'll go into the challenge. Stephanie from Porterbrook will kind of outline the challenge statement shortly, and then we'll go through the solution. Liam, it might be worth going on to the next slide. So yeah, so I'll just do a quick introduction of Infinitive Group. Over to Stephanie for the challenge. Gavin will take us through the solution and parts of our platform products that we used to aid the results, which Stephanie will then go back through. So next slide, please. We've done the introductions, but one addition to that is during January, Gavin was nominated and successfully awarded with Innovation Award through the Rail Innovation Group. So good congratulations to Gavin. So Infinitive Group, as I said, we're a founding member of the Rail Innovation Group. We're a specialist consultancy with engineering and technology, but we're positioned at the intersection of operational know-how and information technology. So we come collective with the domain knowledge and the complexities behind the railway and the transport vertical, coupled with the powers of technology that's outside. So we do quite a lot of knowledge transfer from other industries, other tech that's being developed and matured outside of rail, and bring that in to enhance what we can bring to the railway. I've personally been with the railway now for 16, coming on 17 years, and collectively through Infinitive Group, we have in excess of hundreds of years worth of rail experience, plus similar experience within the technology world. The way that we approach and work with the industry is we work in two kind of veins: services and solutions, and they hand off with one another. So we provide rolling stock systems engineering, technical project management, complex problem solving, but those whilst we provide services through management advisory aspects into the industry, that informs our R&D department, which Chris Blackburn, who our CTO is in charge of, develops platform products, where we've got 3 core platform products, which we'll be talking about one core part of that today, which is Artemis, and how that was then used to discover and define algorithms that were being able to be used as predictive algorithms into Porterbrook's own data lake. So quite agile with the way that we approach things. But we're mainly focused around the output of services and solutions into business, tangible business outcomes that really drive improvements into the railway. And we like to then make sure that that's then measured and there's a true measure of success. Next slide, please. The group, Infinitive Group, have got 3 core pillars to our business. Management advisory I touched upon. That is a real key part. We're our own investors in innovation. We use the management advisory services not only to generate cash and revenue for us to be able to invest into innovation that's purely funded by ourselves. We also use it as a knowledge capture and a knowledge transfer into the business to make sure anything that's in flight, in development, is able to be pivoted pretty quickly if something's changing or trends are changing in the industry. But equally, if there's challenges or problems with the industry is seeing at the cold face, we can quite quickly react to what is required at the end customer, be it an asset owner, which we're talking with Porterbrook today, or be it a rolling stock operator. And in this vein, it's West Midlands Trains. But that's a very important vertical for us, because it, as I say, it drives revenue into the business to enable us to reinvest that back into our own innovation, but it also drives knowledge back into the business. That's combined with then the engineering and technology route, which is focused around the solutions, and that's the culmination of management advisory and the research and development. So it kind of really nicely sandwiches the solution, which could be our own products, or it could be another. We've through the pandemic, we've been diversifying, and part of the diversification that we've been working towards is how we can actually leverage other technologies, how we can become distributors and channel sales through other technologies that may not be coming directly out of our own development, but might complement some of the solutions and offerings that we have. So we can really start to drive the best offering for the end customer at the best price, best price that then delivers the outcome that is needed to be achieved, be it reliability improvements, cost reductions, asset life extension. That's very much what we're focused on, tangible business outcomes, and really challenging that status quo around the business that has been largely focused around tech that might not necessarily be fully linked into the ultimate end goal. So if you extend something out, you need to look at how the biggest aspect around the maintenance regime, you extend everything out, and how the bigger picture we can provide that through our domain knowledge within the railway. So that's a very powerful angle that we focus on, and we're really starting to get some really good traction and some great results, which we're pleased to be presenting today with Porterbrook. So on that note, I will hand over to Stephanie to describe the challenge that we collaborated with Porterbrook on to solve. So I think that will be the next slide, Liam.
Thanks, Liam. Yeah, and if you go on to the next one, it kind of gives a bit more context. So I guess one of the important things to state is that the digital space of Porterbrook is quite a new space for us. So I joined the business just nearly 2 years ago, but really to kind of understand what digital meant for a rolling stock owner. And one of the things that I was keen to do as part of that role was really drive from an industry or a customer problem rather than drive from the data down. So what's also part of the challenge, and I think what's important about the context today, is this is about using existing data, because everyone knows going to re-instrument vehicles is actually a very lengthy process. So one of the first places we wanted to look at was what can we do with existing data. And Infinitive Group were a key partner in this because of their focus on tangible delivery on the ground. So the 172s, Porterbrook's Class 172s, were chosen because they already had data streams that were live on that fleet. We also knew that that particular operator was having issues with engine reliability. So there was almost a business case there which said, well, there's a price to go at here if we can actually reduce the number of in-service failures on engines and use the data that's already coming off those trains. We can really prove that there's value in using digital and data-driven decisions. The other thing about the 172 fleets is they're particularly sensitive to hot weather. So they see a huge surge over the summer months in their engine failures. From a data perspective, that's actually quite good because you've got quite a rich data set of engine failures, and you can start to look at the precursors to those failures to see if you can unpick that. So really, where we were trying to go with this project and why we got Infinitive involved was trying to move the operator and the maintainers to a more proactive and prognostic position. So currently, well, until that point in time, West Mids were waiting for things to fail and then they would have to remedy them. The idea here was, could we use this data to actually see issues coming? And the fact that we knew that this was quite a big issue on this fleet gave this rich data set and lots of statistics and data science that could be used to actually explore that whole prognostic avenue. So the critical KPI really here was, can we actually predict that an engine shutdown is going to happen? And that was nice because it was a clear KPI that we could then start to assess various algorithms and approaches to. And that really was the benchmark for success. So the challenge to Infinitive went with, here's the data. Here are the failure events. Could you have seen this coming? And can you show us how you can essentially risk profile engines so that we can build the processes on the ground to actually act on that data proactively rather than reactively? And I think that probably gives a fairly good starting position. And I think then, Gavin, are you going to go on to now explain how you guys actually unpicked that problem? Maybe? Or Ben, or is it back to you?
Yes, I think I can roll on to me now, Steph. So Liam, if you're okay to advance the slides for me, please. Thank you. So I think that's perfect. Yep, still there. So in terms of our approach, they're essentially within Infinitive Group's architecture, there are essentially 4 components which sit within the Ramus and Iris is responsible for data harvest and acquisition. Pythoid really is about storing and managing your data. So this involves quite a lot of cloud, a little bit of on-prem, but mainly cloud solutions. And then Artemis, if you like, is the final analysis and visualization part in terms of really what the end client would see the majority of. As Steph mentioned, the class 172s already basically have sensors fitted. So essentially, I guess, in terms of our end-to-end solution, we joined in really a little bit higher. So we were at a stage really the data was in store, and essentially we've extracted it from there and applied analysis and then subsequent visualization on top of that. So I think in terms of Infinitive Group's approach and in terms of how we applied our capabilities, we by our background, we're a mixture of mechanical and electrical. And perhaps what is perhaps the change is that actually we've got a growing number of software engineers, or if you like, in part mechanical and electrical people who have adapted their skill sets to widen their capabilities to problems such as these. And I think in terms of the building block parts of the Infinitive Group solutions, what we try and do is we try and align at an appropriate level to fit in with the client's needs. So in this case, we took our methodology, if you like, and applied it to the problem of engine reliability, taking on board, the environmental or the context, which was from potentially arising from hot weather. We were then able to identify and select the right data, again, focused on the overall business objectives, where we were looking for a proactive prognostic type report that the maintenance staff could actually engage with and actually react to on the ground. In terms of the interfacing, to the data that's already there, it involved quite a lot of exporting and transformation. We were quite fortunate. Essentially, the groundwork has been done, the sensors on board the train, and actually the remote connection was already established. So we were quite fortunate. We were able to actually lift and shift from a digital data source, which was already available. And then finalizing the approach or the methodology, we were able to then choose appropriate statistics, create analytical models that would support the we were trying to deliver on. And then what was really important in this project was that we actually evaluated the cause and effect relationships to look at the necessary changes that might need to be implemented at an operational level, so sort of, you know, at the ground. And what we were able to do is we were able to sort of join with as a trusted partner in terms of working with the maintainer and their staff, and actually try and understand, you know, the way in which they worked and the things that could and couldn't be done. The next slide, Liam, if you can just roll forward. Thank you. So this has a little bit of a visualization. We tried to keep this brief deliberately for the duration of the time we have available. But I think what we tried to do is we tried to actually present the algorithms in such a way that they could be readily understood by the maintainers. The maintenance staff were used to seeing you know, heat map type presentations, and actually what we were able to do was demonstrate on a time and vehicle level really just a singular score based from 3 individual algorithms for vulnerability. And these were based around engine charge pressure. The engine charge pressure can be used to infer the health of the turbocharger. And in terms of some of the refinements within the algorithm, we looked, you know, in terms of inclusion and exclusion of data points. So we worked quite hard with the geolocation data, you know, to exclude depots and other erroneous influences. And in terms of the actual the further vulnerability scores, we developed one for engine fan demand. So this was basically looking at the influence on the cooling system, where the cooling system was not able to remove waste heat from the engine fast enough, potentially due to a blockage of the engine fan. And then the third vulnerability score was the engine coolant temperature. So basically we were looking at the radiator itself, whether the fins were blocked, etc. And I think where the three algorithms came together was in terms of the system on board the Class 172 is interlinked. So essentially the various components actually work together under one under one heat management system, and they need to work in harmony in terms of, you know, and that has to be you know, has to be managed to deliver optimum performance. So in terms of the initial development set, the set of the precursor events were focused looking for the highest severity. And in terms of those highest severity events, they were then linked to the operational events that had caused the most severe outcomes, which were potentially engine shutdown or engine revert to idle. So what we did was we basically grouped and amalgamated those into the top severity events. We were then able to work with WMT's production staff to actually understand, you know, what was it about those events that were particularly severe, why were they particularly painful in terms of operational effect, and that was used to actually sort of build up this vulnerability score, understanding that, you know, they can't stop every single vehicle that is exhibiting some level of loss of performance, certainly looking at the 3 metrics that we defined, but it was to try and give a more holistic view of the overall health of the fleet and allow them to target their efforts where best to apply or to get the best value from. So in terms of the benefits, we were able to pick up from existing sensors on board the train. So as I say, we've got engine charge pressure, we have the location, we have the fan demand, and other similar variables in terms of sig values. We have likewise, we have events in terms of, you know, these are events that are driven from the engine management system, the TCMS. And what we were able to do is we drew that up into Artemis, which was our, if you like, our shadow system, which was complementary, and actually apply further analytics over the top of that. And then actually the end output was an information, a visual presentation. And then that's linked onto the maintenance interventions, which really we saw as the end opportunity to actually draw that into the day-to-day business of West Midlands Trains to maintain their fleet. So in terms of the overall steps, the overall piece delivered algorithms to predict engine failures on the Class 172 vehicles. So we took a large volume of data, up to 2,000 records per day, processed, cleansed, reviewed, aggregated for analysis, and we were always conscious to sense check and actually confirm that they were credible as precursors of failure. So there was a great deal of work went into that. In terms of the proof of concept applications and visualization of the findings, as I say, this is just one of a number of visualization tools. But the premise was really that we wanted something to continue to be readily identifiable and relatively simple in its presentation to the end user. And in terms of the end output of all of this work, the analytics included predictive failure risk scores, which allowed trains to be redeployed potentially by using operational capacity in terms of putting them on lower capacity routes until maintenance could be rescheduled, or indeed they could be worked back to depot for retrospective maintenance work. So that basically concludes the summary. And if Liam, if you can roll forward, I'll just pass back to Steph to conclude and sum up the results.
Yep, thanks, Liam. If we just have the next one. So I think there are a couple of really important things there that Gavin's just shown. So firstly, the risk scores. So what we're trying to essentially do here is profile risk across the asset. And in this case, we've chosen engines, but there's no, we're going to go on to look at other subsystems as part of a bigger piece of work. But the idea that those risk scores are not only based on failure mode, but also impact, that's actually quite critical, because as Gavin's kind of said, the most important thing to a train operator is availability and reliability. They can't be taking trains out of service just, frequently, because they actually haven't got capacity to do that. So having a risk score that looks at impact as well as the precursors to failure actually helps prioritize which ones need the most attention soonest. The other thing about the prognostic model that Gavin kind of showed on the previous slide, you could see the heat maps kind of increasing in color to red when things were becoming critical. Part of the brief was about trying to give at least 2 weeks notice that something was going to fail. And the 172s actually revisit the depots pretty much every day. So the idea was, could you tie in prognostics and proactive maintenance into the normal depot cycle without actually having to replan vehicles, because they were going to be there so frequently? So that's another key thing about the data-driven approach is, can it slot into the existing processes, or do you actually need to fundamentally change what's happening at the depot from a planning perspective? If it's the latter, that's a much bigger challenge. And I think Infinitive's approach here was actually instrumental in trying to slot in a workable solution into an existing environment, and that was a real plus point on this. So I think really, as a result, Porterbrook has signed an agreement to go into what we're calling a performance partnership with West Mids. And this project was an underpinning part of that, because it showed how we could really deliver value to our customer, but also kind of be on the ground with them, feel their pain, understand their problems, and really get into the guts of the solution. And I think Infinitive's approach, by actually wanting to be embedded with the fleet engineers, the engine specialists on the ground, was really part of building that relationship. From Porterbrook's perspective, we're looking to have performance partnerships across many of our train operators and fleets. And this principle of risk profiling key subsystems is really at the heart of that. And obviously the data has to be there in order to be able to do that. So the data analytics at the end of the proof of concept was really looking to, it was showing it was predicting around 70% of the engines that are going to fail. Now, there is a caveat on that, in that there was also quite a high false positive rate, which I know Ben, Gavin, you guys were aware of, and we've subsequently done work to look at that, because again, there's a balance between, we can't pull every vehicle out of service. We're not going to get hands on every vehicle, because it takes time to actually inspect and remedy these. So false positive rates are actually just as important as accuracy rates. So there was such huge potential shown here. It really set the foundations of some underpinning principles as to how you could use data to move into this more proactive space. And the partnership really that we signed with West Mids was part of the proof that that we've got a customer base that's interested in this type of approach. And I guess from Porterbrook's perspective, that's where we're really driving all of our key fleets. And actually at the moment, we've got 6 DMU fleets where we're applying the same principles, and the models that Infinitive started based on the coolant, fan demand and boost pressure are all very much at the heart of those 6 individual DMU targeted initiatives. So I think that kind of gives a summary, hopefully gives you a bit of a flavour for what we tried to do, what we actually did, and perhaps also some of the challenges we had as we went through it. Ben, hand back to you.
Thanks, Steph. I think the next slide, Liam, was really just opening it out to the everyone that's in attendance to see if they had any questions and whether or not they wanted to dive into any more detail.
Well, I'm going to take the monopoly on the first question because I'm allowed to. Thank you very much. Also, that was very seamless handing across to each other. I know that there will be technical questions following up, but I just thought in terms for the group, could you also cover off what did you learn along the way? As in, what lessons learned, or how would you approach this differently in future?
I'm happy to answer that first. From a customer perspective, I think the processes on the ground are actually often the most difficult part. Not at all underselling any of the work Infinitive did, because it was fantastic, but I think actually having them on the ground and building that trust within the depot teams was critical, because one of the challenges we've seen at Porterbrook is we can do some amazing analytics, but if you haven't got someone on the receiving end who's actually going to change the way they're doing things, that data has no impact. And I think that's from the experience across the other 6 train operators who have done a similar thing. Each one has had its own different challenge with getting those processes embedded with the staff on the ground and the trust in the data.
Yeah, I completely agree. And that's one of the biggest learning, is that we often talk at Infinitive Group about technology, people and process. And without all 3 harmonized together, it's really difficult to embed sustained change. And that was definitely a huge part of the success of this, was getting the maintainers, the end users, confident that what they were seeing was actually true and it was reflective and it wasn't just made up and it wasn't just voodoo magic. There's some great stories on other aspects that we have done where we've predicted with heat and vent failures, where Gavin had asked a train to be particularly stopped because we thought that there was a fan blade broken, because of the data was telling us that, and it wasn't believed at that point until we actually convinced them to stop the train and open up the cover, and the fan blade fell out. So, and then they really did believe, and it was that trust that then was implicit and put into Porterbrook as you know, the operator's customer. Porterbrook were the end provider of that support. So gaining the trust, working with them and making sure that you understand the complexities around the operational data and how that you can then influence it, because I spoke about at the beginning point about the operational know-how at the intersection of the information and technology world. Just going at it from an information and technology angle, you wouldn't understand the complexities around the availability, making sure that you balance that between the two, because that's really, really valuable, and make sure that you get that emphasis around what you can target, what you can prioritize, to make sure you're getting the best out of the railway.
I'll take that one step further with a specific example of the whole people and process bit. So there's an old engineering adage that if it's stupid but it works, then it's not stupid. So when we went to the depot and spoke to them, as data engineers, our classic first example is you need a dashboard. You need a nice web page with some HTML5 and some CSS, and you'll interact with it this way. We'll render it. They went, right, but I want a spreadsheet. Right, but the trouble with a spreadsheet is that we'll have to send a new one every day and it won't update us. Right, I want a spreadsheet. I want a pivot table. I want it colored like that. That's what I want. Okay, so we find out a way to make you a spreadsheet, right? But the thing is, they were right, because that meant that the people on the technical people on the ground who don't care about dashboards and work with spreadsheets every day actually used it, and that was critical to making it a success.
Right, so building trust as well. Okay, thank you, Lucas. You've got your hand up.
Thanks very much for a really interesting presentation there. So my question is quite a generic one to the group, is when you undertake this data analysis in the management and advisory role, Can you use this data in your research and development area, or is it property of a client? Are there issues with privacy and protecting information, or is it quite a collaborative mindset with this data sharing?
Sure, I can answer that if you want, Ben, or
Yeah, I'll come back as well after.
Because I think it's a really good question, and actually the answer is it's on a case-by-case basis, Lucas. So it just depends, and that's one of my kind of personal missions within the whole role, is to try and get data more widely shared and exposed. And I think there's a natural cynicism and also almost paranoia around sharing data. So, you know, the intention, we're doing a lot of work with RSSB, and, you know, this project's one of those where we're looking at, can we actually share that data? I think you'll have more chance of data sharing if it's historic. I think the live feeds are the ones where people are very sensitive about it. But it's always a challenge for every project. And Ben, I'm sure you've probably seen similar things across other customer bases as well.
Yeah, no, you're dead right. It's a case-by-case basis. We would like to see it go into an open data sharing model. Everything is going out open source. I think we will get there. It's a long way off. What we use and where we leverage that within our management advisory and research and development, we don't necessarily use the data, but we'll understand the concepts which will frame certain methodologies and techniques that we can then apply as and when, as we kind of modularize it, so we don't have to then go back to square one all the time. So it's on a case-by-case basis at the moment, and we try and partner and collaborate with the clients like Porterbrook and others in a way that it's seamless in the way that we work. So you can be a lot more agile in that way then.
I also find that a lot of the problems is reputational risk and exposure. So if you anonymize the data, if you strip out car numbers and strip out locations and make it generic, then people get a lot more comfortable with sharing data.
And I think I would echo that. I mean, we have actually used some open source data to actually train and refine our models for things like pumps of small electrical machines, etc. You know, look on any railway vehicle, you'll find, you know, pumps, motors, small electrical machines. So, you know, they're perfectly, you know, the data is there from a variety of sources. It doesn't just have to be the railway, and we've used quite a lot of that data to actually run that through our models, you know, in a test and evaluation way. So training and learning sets, and then building up models from that. So I think, yeah, we would be quite firm advocates of that. It as I say, there's ways and means. I mean, you know, we've used a variety of data sets from automotive, railway, and other industries that are similar to our own. And yeah, we you know, I can tell it's from a small electrical machine. I don't know whose small electrical machine is. I don't really know what they did with it and what the business outcome was, but it's perfectly useful in terms of, you know, I've got a classification for it, whether the motor is healthy or unhealthy, and I can use it to stimulate my thought making processes on how I could build up a model based on channel information for temperature, running speed, torque, current, etc. So I think anything that the railway can do to support that, you know, being obviously sensitive to business protection, information protection, but I think it has a place to as I say, excite and stimulate and promote debate and thought and discussion from not just within the railway, but also potentially from other people in other industries who are doing similar studies and approaches and work.
Great. We have a question from Gary. You've got your hand up.
Hi, I'm a little bit interested in the hardware side of things, from sensor to the comms gateway on a train. Could you explain that a little bit more? And did you have to work with other solution providers to get collaboration, to get access to maybe a gateway, for example, or anything else that's already on the train? And how many class 172s are gathering data for you at the moment?
Do you want me to answer that? And then Chris, I might need you to jump in for some of the deeply technical bits. So Gary, because they're Bombardier, there's a Bombardier Turbostar, and so there was already a Bombardier system on there, which we paid for a modem upgrade essentially just to get that reinvigorated and reconnected. So that program took place 2018, 2019, I believe. So we have 69 Turbostar vehicles in the 172 fleet. not all of them are reporting. So that again is another a good bit of learning here, in that we tried to reinvigorate an old system and it wasn't 100% successful. I don't know, the other part of your question might be, Chris, have you got further information that you wanted to kind of share on?
Do you want to go, Ben?
Well, I was just going to say, for this particular project, Gary, we didn't have to negotiate gateway comms from sensor to get it out to the wayside, because it was already done, and that was what we were leveraging. It was the existing data and how we could best leverage that to maximize the return, so not having to put additional capital down, and leveraging what Porterbrook had done in 2018, 2019. But for other types of projects where we've been involved, yes, you would look at what systems are self-monitoring, that you can harvest data for, that you can connect to. And at that point, we would always recommend connecting to an existing backbone or gateway to, again, be most cost effective and efficient. And again, it's kind of case by case. Each rolling stock is different. Each requirement will be slightly different. We always leave it open and future-proofed for maximizing what you can get out of it in the future.
So yeah, a good example to give you a bit more further detail, Gary, for that is the MyTrack system, implemented by the artist formerly known as Bombardier, is an event-driven system. So it looks for various faults on the train, like air conditioning compressor 4 is broken or something like that. And then in each event, there's a section of environmental data, which is just a snapshot of what the sensors are reading when that event happened. There are certain events that are fed into the system, like departure data log, which happens every time the train leaves a platform, that have sensors associated with them. So you go, right, well, that happens often enough that we can kind of treat that like time series data. Even though it's intermittent, we kind of build up a picture over time and see roughly what the engine's doing. And that's how we built our algorithm. So what you do is you can use the existing data to prove the concept. And then you go, right, so because of the number of data points we have, I can give you 14 days notice for an engine failure. If you let me retrofit a data logger and I'm recording 10 times a second, I can give you 24 hours notice for an extra, like a big window that will give you more opportunity to deal with the engine. So we can see a degradation over time and look for spiking events and do more correlation. So you can get, this is what we can get with what the data we have. Would you like something bigger if we spend some more money? And that's when you're in business case territory and accountants get involved.
Great. Ray, you've got your hand up.
Thank you. Yeah, really interesting presentation. I wanted to ask a bit about the cost benefit study and how that goes back into the TOCs and the Department for Transport's cost savings to the operations of the railway, because obviously there's clearly savings being made by more efficient maintenance and advanced notification and servicing of vehicles. That was my first question. I know some of the Bombardier units, the 171s, which I think are Porterbrook as well, have been quite unreliable in the past. But I know that they've driven, I won't mention the TOC, it'd be unprofessional me to do so, it's driven some great efficiency in the last couple of years, but still there's challenges, and I'm guessing this technology will help that TOC in getting best out of those units. And thirdly, my question would be, I know Intuitive, obviously very smart in the industry with data. Where are we, and maybe this is a left field question and might be for an after discussion, where are we with getting data off trains for passenger loadings, number of bikes on trains, and demand forecasting going forward post COVID-19? And the other point of that is when there's disruption and we need to get some rail replacement buses in place quite quickly. Probably a bit of a loaded question, but a few points there. Thank you.
Quite a lot, right? If I start with because I can start with the business case one, which actually is the most difficult question. And the reason we chose engines is because we did a Pareto analysis of which were the highest hitting delay causing issues, and engines came up as being one of the top 3. And the idea was, well, we know that delay penalties are in place through Schedule 8 and Schedule 4. So as a result, we can actually put some pound signs around this. Whereas other failure types or mechanisms actually are really difficult to actually put a value to, because the industry is so complicated with the train operator, the rolling stock owner, the maintainer, the level 1 to 4 maintainer. There are so many parties that so as a Roscoe, where we're looking to go is we're looking to actually, perhaps for some of our customers, actually become embedded with their risk to some extent, where we almost commit to a level of performance, a bit like a TSA, but not a TSA, because it's going to be very subsystem specific, but it's all focusing on reliability. But I think that commercial connection is still not clear. And actually, that's why this is quite a brave initiative on Porterbrook's part to some extent, is that we've thrown quite a lot of money at this to actually, because we think it's the right thing to do, but we're not quite sure how we recover it commercially. And I think the industry post-COVID, especially with the Irma situation and the fact that DFT is now pretty much the purse holder in every situation, removes the competition element between train operators, which actually is a good thing sometimes. And that overall system incentive for better performance, I'm sure that over the next few years, we'll see the commercial connection to each of the parties and their responsibilities and how they actually get recognised for that. So at the moment, on the 172s, if they perform better, I don't get any extra money for that. But that was part of this, was to kind of do it anyway and hopefully work that out over the next few years.
That's an interesting thing, because in the pre-COVID world, there were franchises and there were franchise commitments, which were nice and easy, because thou shalt reduce delays by 25% or you will pay a penalty of X. You go, there's your business case, done. Now, I think engine reliability is a pretty safe one. I'm pretty sure that the DFT is going to want more reliable trains, but I'd hate to preempt what their real priorities are, because I'm not even sure if they've figured out what their priorities are yet.
Yeah, it's a complicated one. The other one on passenger loading, I think there's a really good, so RDG have the GPS gateway, and there should be something similar for passenger loading if there isn't already. And I think that's something, again, on Porterbrook's front, we have obviously a whole range of legacy fleets, some of them that have absolutely no digital capability and other ones which do. And for all ones that do, we're really looking at the passenger loading capability. Now, fitting automatic passenger counting is actually, again, quite a big thing to do, but there are other mechanisms such as using Wi-Fi. Gary, I know this is in your field of expertise, but you can count number of Wi-Fi devices and give an indicative passenger load. So things like that we're exploring to say, can we actually help inform the industry, which again, if that information can be fairly real time, helps in times of disruption, because you're actually able to respond to a true case, knowing exactly which are your most loaded services, what's the impact, rather than something at the moment which is very uninformed. I don't know, Ray, does that answer your question?
That's brilliant. Thank you very much, Stephanie. Cheers.
If I just come back also on the passenger loading, part of our analysis on data acquisition, Gavin went through some of the platform products in which we've got, and one of them was Iris on there. And we've recently been developing our own sensor technology, because where we've been harvesting and acquiring system data, which is from existing systems that are monitoring themselves or systems that could be monitored by other things. One area where we felt was quite weak and quite restricted was the acquisition of passenger data. So yes, you can measure airbags on suspension. Yes, you can measure passenger counting at doorways, which claim to be accurate and generally are less than what they are. And you can do that through CCTV, and there's many ways that you can do that. What we've now been doing with the development through COVID is utilizing our Iris technology, which is essentially radar for scanning of objects and people on moving. And we've one of our, Liam congratulated everyone for submitting first of a kind applications. One of our applications is the deployment of that for a similar use case around loading and how that can be used and how you can then maintain social distancing. And I also noted that McLaren applied are on the call today. We're also in a collaboration agreement with McLaren to take over the seat reservation and occupancy sensor, which will be rolled into the wider piece around acquiring more knowledge around passenger, and that's all part of the strategy and roadmaps around that for Infinitive Group and how we can help support that.
Great, thank you. Anna, you have 2 minutes.
I'm going to be very quick, and it's a very quick question, of course. So first of all, thanks. It was brilliant. It was really, really interesting. And I just want to sort of pick up on Ray's question about the business case. And it's quite interesting that he said it isn't actually really a business case for Porterbrook at the moment. So my question is actually a very quick one. Do you and Infinity and Porterbrook, or Infinity with in the future, do you intend to sort of do a similar project on other fleets, or what's the intention or the plans there? Will we see this anywhere else?
Yep. I think the quick answer from both parties is yes, in that we've already launched this type of project on 6 other DMUs that Porterbrook and that is across 6 different train operators. And I mean, I certainly hope that there'll be long-term engagement between Infinitive and ourselves, because I think that their approach is really fundamental to really embedding this type of thinking in with our customers as well as with our supply chain. Ben, I don't know if you...
Yeah, no, I agree. I mean, the business case is a hard one. It's a hard one to challenge. It will change from TOC versus Roscoe, and it totally will change now with regards to post-COVID world. So, I mean, it's always part, and we work up and try and focus on the business case and where best to do it. We're also doing another project for another client on light rail, and we started with simulating what remote condition would look like through manual means. And we've now helped them through the business case creation, and we've demonstrated a hugely positive business case that is, as we speak, going through their exec approval. So it can be done. There's ways of doing it, and depending on what's the driving force, is it reliability, is it availability, is it maintainability, is it asset life extension? There's all those different elements. I deliberately didn't mention safety, because that's a given and everything should be safe.
Thank you very much for that, and perfectly on time. Thanks, Anna, for your very brief question. Thank you very much to all the presenters today. Very interesting, and also a great good news story. We actually have a session next week at 12, which is going to be hearing from Junction and Travel Space about a social distancing solution for onboard trains. So join us again next week at noon. I guess last thing is, thank you all for coming. If someone from Infinitive or Porterbrook wants to mention how anyone can find out more, or where should they head to, then now's your chance.
Yeah, sure. If you want to reach out to us, you can get me either on LinkedIn, Ben Craze, or you can send us an email at info@infinitivegroup.co.uk, or myself, ben.craze@infinitivegroup.co.uk.
And same for me on LinkedIn. And again, if anyone on the call is interested in this kind of space, which is this whole risk profiling, the asset kind of tight connected thing between also track monitoring as well as train monitoring, really interested to hear anyone's thoughts.
Great. Thank you for your time, and thank you to our presenters, and see you next week.
Thank you, everyone.